Hello, in video number 29, we discussed the important commands for logistic regression. Basically, in our video number 29, we added only these three lines where we added the constant to our x variables and log reg is equal to sm, which we have taken it from stats model, and logit yx fit, and then we printed the summary. This is what we did in our last video. I'm just going to name it as logistic regression. Okay, now if we run it again and here our variable is 4, dependent variable is 4, 1 2 3, that is age, income and debt income ratio is they are our independent variables. And just going to close this file because it will not rewrite the file if it is open. Just going to close it, and then I will say enter here, and this has worked. So constant is there minus 1.0154, age coefficient is minus 0.5, y12 income coefficient is 0.005, and only the which is statistically significant is age and debt, what is coming up. But we showed you the file. I again show you the file. I'll first delete this. I don't need it. I will take it up df4 file here only. I'll say run, select the file test12, the 4 is 1 2. So this is where we have found out the default. These are the actual default 1 0 0 1 1, and these are the predicted defaults. If the probability is less than 0.05, it will give you 0. If it is more than 0.05, it will give us a 1. Now my question is, how many predictions are correct and how many predictions are not? We will show it in the form of a matrix. We usually call it confusion matrix, and then we will try to find out how many predictions are correct. So I'm going to open a new Jupyter file. Now here I'm going to write it here. This is a new I'm going to write it here as matrix confusion matrix. Matrix confusion matrix, which was our y was our default. Y is our default, which we have already created in this. df3 is we have we have formed a new variable in df3, data frame free, and with that this predicted label. Now this one was, if probability is more than 0.05, it will be 1. If it is less than 0.05, it is 0. And then we will frame a confusion matrix display. I have just named it as C display, matrix.confusion matrix display. It will display the confusion matrix and the labels will be yes or no. And that you are already you have put the files. So will plot, plt will show, and you can also print the cm, and then you you can see the accuracy. Accuracy is also coming from metrics.accuracy underscore ydf3 predictable, and it will be rounded up to 2 decimals. So I repeat the new commands which are going to come. Matrix.confusion matrix, which is your y, that is default, and df3, which is created as predicted label. And then it will C display is another variable, other array. So it will have matrix.confusion matrix display, confusion C capital, matrix M capital display. And confusion matrix is what? CM, and display label is yes or no. So let us work on the next thing, and we will start working. I'll just copy it. I will add another cell and copy all the, now here it will, I will name it as confusion matrix. Matrix and accuracy. Okay, so we are just going to write this. Let us copy first the files which we have taken up, which we will take it up from this one, regression logistics. I'm just going to copy it. These are all just old commands, might have learned it, and I'm just going to copy this, copy paste here. That's all these are all old commands, nothing new. To open the file, open the folder, then open the file, and then you are going to import all other functional packages, enter, pandas, math, cbar, numpy. See, matplotlib going to be useful now to make the confusion matrix. And then, so this is what we are going to learn, and I have just copied this. These are the new commands which I have copied on the, let us run. It will open, let us open the file test12. My dependent variable is number 4, that is default. Independent variable is 1, 2, 3, that is age, income, and net income ratio. So this is what the coefficients and everything which we have learned in the last session, and this is the confusion. Yes to yes is 351, yes to yes is 351, no to yes is 92, yes to no is 20, and no to no is 36. So 351 and 36, they are correct. Yes to yes, 351 is correct, 36 is correct, no to no, they are correct. 351 plus 36 divided by total 499 should give you the accuracy. So accuracy table is 0.78. So this above table, table which we have created by matplotlib, so this can also be simply shown by this way, but this people will not understand what is this metric. So this is the command we have written it here, print cm. You don't want to print cm, this will not come. In this video, we have learned how to make this confusion matrix and as well as the accuracy. Thanks for watching. More videos are coming on data analysis with Python. Thank you.